Hey guys, welcome to day 34. Today we're going to talk about parallel and perpendicular lines. If you notice the first example here, we have two lines. They're parallel. If they continued on and on, they would never cross, okay, kind of like train tracks. Okay, and if you look at the slope of both of these lines, they're both positive, and if you notice, they're actually the same steepness. So the slope of parallel lines are actually both always the same, okay? The slope of parallel lines are the same. So if I wanted to write the equation of line A, I would first look at the y-intercept, and if you can see, it's crossing here at 6. So my B is going to be 6, and if I calculate my slope is actually going to be, we're going to start maybe from here, rise 2, run 1. So my slope is 2. So my equation for that line would be y is equal to 2x plus 6. Okay, looking at the other line, line B here, I've got a y-intercept, so my B is actually going to be equal to -4. And my slope, if I rise 2, run 1, is also 2. So my equation for this line is y is equal to 2x minus 4. So if you notice, they both have a slope of 2. They're parallel. All right, looking at the second example, we have two horizontal lines. So I'm going to think of HOI. Okay, HOI meaning the equation of the line is y equals. So if I looked at line A, I cross right here at 1, 2, 3. So the equation of the line is just y is equal to 3. Now, a parallel line with also a slope of 0 would be the one right here, and we're crossing the y-intercept right here at -2. So the equation of that line would be y is equal to -2. Okay, now I'm looking at two lines and they're both negative slopes. If I look at the first one, look at line A, my y-intercept is -4. So it's right here at -4. So that would be my B, or my B is -4. And my slope, if I go down one to the right, is actually going to be -1. Okay, so my equation for line A is going to be y is going to be equal to -x minus 4. All right, and then if I looked over here at, this is line A, line B, I've got +3. So if I look at that, my slope is also -1. So I've got y is equal to -x plus 3. Okay, so what we notice about the slopes of parallel lines have the same slope. So let's write that in our notes. Parallel lines have the same slope. Okay, now moving on, okay, we look at the next one. Now we've got perpendicular lines. And if you notice, they actually meet at 90-degree angles. Okay, and we're going to write an equation for each of the line in the space provided. So if I look at line A, my slope is going to be -1/2. Okay, and my y-intercept is actually 0. I cross right at the origin. If I went 1, up 1, and then to the left 2, my slope would be -1/2. So my equation for line A would be y is equal to -1/2 x. Now I don't need to say plus 0, so I'm just going to leave it at y is equal to -1/2 x. Looking at the other line, it looks like I'm crossing right here at 1, okay? My slope in this case is up 2 over 1. My slope is going to be +2. So the equation of this line is y is equal to 2x plus 1. All right, so comparing the slopes, in one case I've got a -1/2, and then the other case I have a 2. Okay, let's look at the other ones and let's see if we can come up with a pattern. All right, so if I look at my next example, I've got my line A is right here, and my y-intercept is going to be at 0. My slope is going to be rise 1 to the left 3, so my slope is going to be -1/3. And my y-intercept is 0. So my equation of the line is y is equal to -1/3 x. Okay, if I look at the other line, my y-intercept is at -4. And my slope, if I look at my slope, will be 1, 2, 3 over 1. So my slope is 3. So the equation of that line is y is equal to 3x minus 4. Okay, so now we've got a slope of -1/3, and then we've got a slope of 3. Okay, so we had negative 1/2, and then we had 2, we had negative 1/3, we have 3. Let's look and see if we can come up with a pattern. So looking at line A, let's get the third one. In this case, our slope is going to be, if we look at this, well, first let's do the y-intercept. It's going to be crossing right here at 3. And our slope is going to be, we go 1, 2, 3, 4, and over 1, so it's going to be a negative 4. All right, so the equation of line A is going to be y is, whoops, let's go back. Y is going to be equal to negative 4x plus 3. All right, and then if I look at the second one, the line is crossing right here at negative 3, and our slope is actually, we go up 1, 1, 2, 3, 4, so our slope is positive 1/4. So our equation is y is equal to 1/4 x minus 3. Okay, so now I've got a slope of 1/4 and a slope of negative 4. Okay, so if you notice these, and I'm going to put our whole numbers over 1 to compare as a fraction. If you notice, if we take 1/2 and we take the reciprocal, meaning we flip the numerator and denominator, we're going to get 2 over 1. 1/3, we would get 3 over 1. 1/4, we would get 4 over 1. And notice, if one is negative, the other is positive. So what we can notice and conclude about the slopes of perpendicular lines is that they are the negative or the opposite reciprocals. Remember the reciprocal, it's kind of like you're flipping it, or the refliprocal, I like to think of it as. Okay, so they are the negative, okay, or opposite, right? Meaning if one's positive, the other's going to be negative. Okay, because if you notice, we've got a positive slope here and a negative slope here. Positive slope here, negative slope here. Positive slope here, negative slope here. So they're always the opposite reciprocals. All right, so moving on. Okay, it says, and here's a good example, actually a good picture. If you notice, we've got two parallel lines. The equation of the red one is 2x plus 1. The equation of the blue one is 2x minus 3. If you notice, they're parallel, and if you notice, they have the same slope. Okay, here's an example of perpendicular. All right, here it's negative 3x plus 4. And this one is 2/3 x minus 3. They meet at 90 degrees. And if you look at it, the slopes, we've got negative 3/2, and then we have positive 2/3. So it's actually the opposite reciprocal. Okay, so if two non-vertical lines, and I'm going to move this over just a little bit, make some room. Okay, if two non-vertical lines have the same slope, then they are parallel. Okay, and we're going to use a symbol for that. So let's write in parallel. Okay, we use the symbol that looks like this. It's got two lines, like two slashes like that. Okay, so in my example, if I had line A, my example was y is equal to 3x plus 4. That's a plus 4. And then for line B, okay, if I had y is equal to 3x minus 2. Okay, we notice they both have the same slope because we always look at the equation in slope-intercept form. And when we do that, if we've solved for y, the m is the slope. In this case, line A, okay, line A is parallel to line B. Okay, if two non-vertical lines have slopes that are negative reciprocals, okay, so negative reciprocals, then they are perpendicular. All right, and I'm going to pause here. Okay, so again, if two non-vertical lines have the same slopes that are negative reciprocals, they are perpendicular. Okay, the symbol that we use for perpendicular looks like this. So the symbol is going to be kind of like an upside down T. So in our example, if we had line A, and line A was y is equal to 2x minus 1, and then we had line B, and line B, we had y is equal to negative 1/2 x plus 4. If we looked at the two slopes, one is 2 and the other is negative 1/2, you can see that they're negative reciprocals. So we can say that line A is actually perpendicular to line B. Okay? All right, so Moving on. All right, so if we have, let me move this on over for you. Okay, the question says, write an equation of a line that passes through -3, -5, and is parallel to y equals 3x minus 1. I want you to get in the habit of highlighting. So equation of the line, and let's see, parallel. Okay, so let me change my highlighting color to better. Okay, so I want to write an equation of a line. By default, an equation of a line is always in the form of slope-intercept form, y equals mx plus b. Okay, and we want this parallel. So that means I look at this line here, this equation, and I pull out my slope. My slope is 3. Okay, so a parallel line actually would have the same slope. So I'm going to use that slope with that point and go back to our point slope form again. All right, x minus x1. And I'm going to put in this point. So I've got y plus 5 is equal to the slope 3 times x plus 3. Okay, we're subtracting a negative. All right, so this becomes y plus 5 is equal to 3x plus 9. And then we'll subtract 5 from both sides, and we get y is equal to 3x plus 4. That's our answer. Do we write the equation of a line? Yes. Okay, so number 2. Again, we're going to look at the we're going to highlight, write an equation, so an equation of a line that passes through -2, 11 and is parallel to that equation there. So luckily this is already in slope-intercept form. It's not always going to be that way. We can pull out our slope. Our slope is -1. We're going to use this point in point slope form. This would be y minus 11 is equal to -1 times x plus 2. All right, I'm going to just distribute this, -x minus 2, and then I'm going to add the 11 to both sides. Okay, when I do that, y is going to be equal to -x plus 9. Okay, moving on to number 3. Okay, we're going to write an equation of a line that passes through this point and is perpendicular. Okay, so perpendicular, it's a different type of slope. So if you notice, this slope is 2. The perpendicular slope actually is going to be the negative reciprocal. So if this is positive, we're going to make it negative, and it's going to be the reciprocal, -1/2. Now this is important. We're actually going to use this slope right here in point slope form, not the slope of the original line. Okay, so we're going to pass through this point. It would be y plus 5 is equal to -1/2 times x minus 4. Okay, notice we use that -1/2 slope. So we distribute y plus 5 is equal to -1/2 x plus 2. Subtract my 5 from both sides, and I end up with y is equal to -1/2 x minus 3. Okay, this would be a good place to pause and actually try number 4. Okay, and just start me back up again when you finish. All right, so now that you finished that, we're writing an equation of a line, and it's going to be perpendicular. So this slope is 4. My perpendicular slope is going to be the negative reciprocal, so it's -1/4. I'm going to use that new slope with that point. Y minus 3 is equal to -1/4 times x minus 4. I'm going to distribute y minus 3 equals -1/4 x plus 1. And then I'm going to add 3 to both sides. So the equation is y is equal to -1/4 x plus 4. Okay? All right, so number 5 says determine which lines in each set, if any, are parallel or perpendicular. So we want to see if they're parallel or perpendicular. Now to do that, we need to figure out the slope, okay? So the first one, number 5, line A is really easy. The slope is 5, okay? Because we can just pull it out. We're in slope-intercept form, okay? But for any of the others, we might have to put it into slope-intercept form to pull out the slope. So be careful and actually show your steps, okay? So for this one right here, we've got 5y, so we're going to subtract x from both sides and get 5y is equal to -x plus 2. And then I'm going to divide each term by 5. Y is equal to -1/5 x plus 2/5. Okay, so here my slope is -1/5. Okay, and then this one, I've got -10. I'm going to divide both sides by -10, and I get y is equal to -1/5 x. So my slope here is -1/5. So if you look at our three slopes, you can see that line A is actually perpendicular to lines B and C, and lines A is actually B